Hi, today's topic is operation of a DC machine as a generator and also EMF equation. So now I am showing the basic circuit operation of a DC machine which acts as a generator. Here you can see there is a coil ABCD which is moving between the parallel axis magnetic field between two poles N and S. When a simple machine consists of a magnetic coil ABCD which is moving about its own axis in a magnetic field provided by a permanent magnet. When the coil is rotating in the clockwise direction, the flux linking the coil changes continuously and EMF will be induced in the coil. So here you can see if the coil sides A, B and C, D are exactly parallel to the axis of the field, it won't cut any magnetic lines of force between NS and EMF induced will be 0. That means when the coil is at position 1, the coil will be vertical, but the flux linking the coil is maximum, but rate of change of flux will be minimum. So as AB and CD do not cut the flux, the EMF induced in the coil is 0. Now if the coil continues to move, then if it is exactly perpendicular of rotation, that is suppose theta is 90 degrees, then the coil plane is perpendicular to the lines of rotation and immediately the flux linked with the coil will be minimum and maximum EMF will be induced if the coil side is exactly perpendicular to the axis of the field. So in the first half revolution, no EMF will be induced in it, and in the next half, that is in the first half from position 1 to position 4, you can see EMF is induced and it is maximum at 3 and again decrease to 4 and it is 0 to 5. Similarly, during the negative half, in the next half revolution, EMF will be again maximum at position 7 and again it decreases to 0 at position 9. So, coming to the next figure, here you can see, I'll just explain the direction of the current. So, these S1 and S2 are two slip rings that are connected to the circuit. So, here as the coil continues moving in the first half revolution, I have already said no EMF will be induced when it is in position 1 and maximum EMF in position 3 and no EMF in position 5. So applying Fleming's right hand rule, which gives the direction from A, B and again back to C, D. So this direction of current will be A, B, M, L and again back to C, D. That is the current will be flowing through the load from M to L. In the next revolution from 180 to 360, the variation of EMF is similar. So its value will be maximum in position 7 and minimum in position 9. So the direction of the current will be from now D, C, L, M, B and A. So that means DC, LM, BA and current will be passed through the load from L to M. So we find that the current obtained reverses its direction after every half revolution. So such a current is called an alternating current. So for making the flow of current into a unidirectional one, these slip rings are replaced by the split rings. These split rings made of conducting material is cut into two halves or segments insulated from each other by a sheet of mica. So in the first half revolution, current flows along ABLMCD, that is brush A which is in contact with segment S1 and brush B in contact with segment S2. So again in next half revolution, the direction of the induced current is again reversed and at the same time the position S1 and S2 will also be reversed. So again whatever the current that is obtained, it is nothing but a unidirectional current. So from this we can conclude that when the coil is rotating in clockwise direction, the flux linking the coil changes continuously and EMF is induced in the coil. If the coil is perpendicular to the magnetic field, maximum EMF will be induced. And if it is parallel to the magnetic field, EMF induced will be 0. So this is the operation of a DC generator. Next, coming to EMF equation of a DC generator. Let phi is the flux per pole, Z is total number of armature conductors, P is number of poles, and A is number of parallel paths in the armature. Now, N is speed in RPM and E is EMF induced in the armature conductors. Then the equation for EMF is flux cut per second. The flux cut by one conductor is equal to number of poles multiplied by the flux. So it is P into 5 Webers. Flux cut by one conductor per second will be N by 60 multiplied by P into 5. So EMF generated by a conductor by single conductor will be equal to 5Pn by 60 volts. Now if we calculate EMF generated per path, then EMF generated in one conductor will be equal to EMF generated in one conductor multiplied by number of conductors in each parallel path. So that means 5Pn by 60 is number of conductors into Z by A. Okay, Z is total number of conductors, A is number of parallel paths. So E is equal to 5ZNP by 60A. So this value of A will be calculated depending on the type of winding. So if it is a wave winding, then you have to put the value of A as 2. If it is a lap winding, then you put the value of A equal to number of poles. So this is the final equation. And I have uploaded lecture notes of Unit 1 and Unit 2 in our store on basic electricity and magnetism laws, and also DC machines covering both DC generator and also DC motor. You can see all topics on DC generators, derivation of equations, types, and everything including applications of generator, motor, and also numericals. So the complete lecture notes is available in our above units. Thank you.